This is a demonstration of the Akumo AMP platform. AMP stands for Application Mobility Platform, and AMP is a very simple way in software to be able to use the cloud for use cases like DR/BC, migration, archival, and other use cases where the cloud is the secondary data center. This virtual appliance is how you access AMP. You just download it to any VMware vCenter environment, and then you install the product. AMP has the ability to manage multiple customers from a single pane glass view. So this is a great feature for managed service providers who have a NOC and want to manage disaster recovery remotely for their customers and also see all the status and monitor the status of DR for their customers. Install is very simple. All you have to do in the product when you initially deploy the product is to log into the UI and specify the vCenter credentials, AWS credentials, some basic networking information that the product discovers within the vCenter environment, as well as basic information about the storage that the product uses for caching locally. The AWS environment and the AWS credentials that are provided to the software are not going to be held by the software. The software uses them to create IAM access keys, and that's going to be used for the rest of the operations for the product. And that's the best practice from AWS. Once these 4 pieces of information are provided, including networking, if a different network is required in the cloud or not, storage, in terms of how much local storage should be used as an initial quota, the product automatically installs in about 10 minutes. At the end of the installation, there's a point-to-point SSL tunnel created between this on-premise VM and a brand new VM which has been stood up during install in the cloud inside AWS with a point-to-point link to this VM, and it's all completely secure. So within 10 minutes flat after installing the product, you can directly go in and operate disaster recovery. The way the product works is very simple. You create groups. Groups essentially are the way that you attach policies to a bunch of VMs in the environment. They have different policy features. For example, you can specify how you like the VMs to be protected. By default, the VMs are protected in a protect mode. Protect mode basically means you want to agentlessly protect the VMs on-prem with folds and incrementals, and the software automatically has connectivity and knows how to talk to the hypervisor inside VMware to do such protections. Clone is a mode which gives you much faster recovery times in the cloud. So if you have applications that you want to actually bring up in minutes, clone is a good operation to set for the group, but at the cost of doing fulls while it's protecting the VM. So if you have a relatively fast network and you have some applications that require faster recovery SLAs, clone is a good option. You specify the start time, the SLA of how often and when you want the VMs protected, and based on that, all you have to do is add VMs to the group. And when you select VMs with a faceted search, you can see which VMs are protected or not, add them to the group, and then you're done. So at this point, the software actually takes over. It's able to automatically protect the VMs in the groups based on the SLA schedule. Additional policies in the group include specifying domain controllers. So the software has the orchestration built in to know domain controllers and how to treat them, especially during failover. Specifically, it has automation to look at the IP addresses and map the IP addresses from source and destination automatically without the requirement for any user intervention. Let's flip over to a different customer account to see what it looks like after protections have succeeded. So once protections complete, the status of the VMs and groups that change to a protected status. You can actually look at the details of the VM. It tells you what disks are protected. It tells you how the IP addresses have been mapped by the product and allows a user or operator to override them if they require. At this point, once the VMs are protected, failing over into the cloud is very simple. Simply select the VMs that you care to fail over, and there are certain actions provided to failover machines in the cloud in test or in production mode. Test failover is special because it basically tells the operator that VMs on-premise continue to be protected on the regular SLA on the policy for the group, but test allows you to independently test those VMs in the cloud, isolated from everything else. So you can run a test, log into machines in the cloud, and if you're satisfied, you can complete the test, and the software will orchestrate the removal of those created resources. For production failover, it's exactly the same as test, except two different things happen. One, the software is going to bring up the production VMs in a different network, which is again specified at the time of production and can be overridden by the customer. And then the protections now stop on-premise and start in the cloud. The expectation during production failover is that on-premise is not active anymore, and then the cloud should be looked at as the source of truth. So VMs that are running in the cloud will be protected on a regular basis based on the same policy or SLA set up in the group once they're running in the cloud. This also allows for fast failback back to the on-prem environment, because now the software knows how to protect the VMs in the cloud and can also compute deltas for moving data back from the cloud back on-premise. So it's a full life cycle for disaster recovery, all the way from protection to test failover and non-disruptive testing, to production failover, and to active failback and bringing the resources back home. It's also got a few other nice features. You can select VMs across groups if you wanted to do that. And in the stage, you can specify the order in which VMs come up. By simply dragging and dropping, you can specify which VMs have to come up first and are more important, and that allows the software to automatically schedule the order in which the VMs are going to be failed over. Again, in this view, you can pick VMs from multiple groups and execute the actions globally across them. In addition to groups, the software also has something called failover plans, and by default it comes with two failover plans. There's a test failover plan and a production failover plan. Failover plans give the ability to specify how you want to fail the machines over in the cloud. Specifically, if you want to just test them, there's no reason to bring up the VMs at a full capacity, because then you're going to be paying more for it. So with a simple scaling factor, you can scale the machines to much less than the capacity required. So in this instance, by default, you're saying that when you bring up machines in the cloud, scale them by 50%. So don't give them all the requirements for compute, memory, CPU, and networking capability. So that will allow you to contain the cost when you're running tests in the cloud. In the case of production, where you really want the workload to run at full capacity, you can change up the scale to whatever you like, and then that way the software is automatically going to make sure that the types of machines it's going to map and bring up in the cloud have those resources required to run a production workload. In addition, you can also tell the system that you want to protect machines in the cloud for crash consistency, as well as specify domain services and which domain control the machines that are failed over should point to in the cloud. The product also gives you the ability to have a much more detailed, granular view into what's happening in every step that the system is doing. So in this case, in the tasks, you can see what it protected, how many steps there are in each protection, and how much time each took, and it gives you a history of the last 3 runs, so you can average roughly how much time protections take for each system in the environment. On the infrastructure side, the product has the capability to throttle the bandwidth, so you don't need any external device for that. You can set up simple diurnal schedules telling the product that you want to only use a certain percentage of the bandwidth during business hours, and off business hours and off peak hours and weekends you can use much more of the bandwidth. So this way the product is not generating a lot of load on the network during normal business operations. On the storage side, the system manages storage independent from compute. So the nice thing about that is that you can specify the on-premise storage and a repository that is used as a local cache when the product is protecting data. And the operator has the ability to manage how that quota is being set. So the product will never ever oversubscribe storage beyond what quota is actually given to it. And on the cloud side, the software automatically computes how much storage is required, so it can asynchronously and asymmetrically use storage optimally in the cloud. In the cloud, the software automatically uses blob storage, block storage, and snapshots, and orchestrates where the data lives at any point in time as a function of both the cost and also the resiliency and the durability of the storage. When this health status goes from green, which is healthy, and as the storage starts to get filled up, it's going to go into yellow and then red, which says its disk capacity is low, and an alert will be sent to the operator via SMTP so that they can go and change the quota on the system or add additional storage if required. So the product gives you the capability to add alerts via SMTP, and you have different levels of status so that you can say what kind of messages need to be sent as alerts. The product also provides details about each of the compute, storage, and networking environments in the cloud. So any status that is relayed from the health information from AWS is collected and curated here. And the software also tries to do predictive cost analysis for compute, storage, and networking so that it gives you an idea of how much capacity you're using and how much your future costs are going to be. The product does support all regions in AWS and all AZs, including GovCloud. So those are the ways that you operate the product for DR and the infrastructure that's part of the system. Now let's quickly take a look at Archivix. Archivix is part of the product for AMP, which allows you to protect CIFS and NFS shares. So it works very similar to the way Continuum works for DR. You can create a brand new host, specify an IP address, and specify an SLA of how you want the shares on that host to be protected. So with CIFS and NFS, the product will automatically discover the shares that you can protect, and then very simply you can set up a policy which says when you want to start protection and where you want to target the data to live, whether it's in AWS or Azure or Google. And then once you specify that, the product automatically starts to protect the shares based on the schedule. And then these additional SLAs allow you to fine-tune how you want the data to be accessible when they're protected. So this is a full hierarchical storage management platform, which means that if you want to protect or store the data in the cloud in fast storage so that you have quick access for a certain amount of time, you can do that. In this example, NFS share here is being protected for the first 60 days to block storage, so you can quickly access it. Between 60 and 150 days, it's moving to blob storage, so the access falls from minutes to maybe an hour or so. And then finally, it's moving to archival storage after 150 days, which means that now to recover that same data, it'll take a few hours, maybe 5-6 hours, but at least the cost for archiving that is extremely low. So it's a very simple operation of how it works, and this works for both CIFS and NFS. The product is licensed separately for DR and for archiving. For DR, it's based on the number of VMs, and for archiving, it's based on the number of data being stored in the cloud. Again, this is a demo of Akumo AMP, and that's about it.